I believe we are live.
I believe so too. And well, this is almost always the most difficult part. You can hear me, you can see me, and you can see my screen. I'm already glad that that worked out today. So, hey, folks, welcome to the Kubernetes Day UK, one of the workshops, and we are going to show you how you can secure your applications with Snyk. Normally, a workshop is actually a workshop, but we will just walk you through a few things so you can actually see what's going on and you can reproduce it kind of yourself, either with the apps we show you or with your own applications. Give us a shout out in either of the comments on either YouTube or Twitch, wherever you are watching. Where are you that you're watching and where you're from? I am Brian. I'm based in the Netherlands, and I'm doing this together with my colleague Eric, who is based in Texas. So I will take care of the first part, and then I will hand it over to Eric to do some of the other things. So let's get going, because one of the first things we need to talk about is this word, DevSecOps. I mean, you probably have seen this word, you probably have heard this word, and the first time I saw and heard of this word, I thought it was just a buzzword. Sounds really interesting, but what does it actually mean? Well, if we go back to the essence of the word DevOps, we probably have heard of that. We might practice it. And if you're afraid of, like, do I actually do DevOps? Think about it. If you are in a development team, and in your development team, you're not only creating the stuff and throw it over the wall, but you actually, to some extent, you're responsible for putting this stuff in production, to make sure that it ships to production, either automatically via a pipeline or whatever. Then you probably do DevOps, because in the end, when things go wrong, they will call you and you have to fix it and you have to redeploy it. So you own what you create. If that's the essence of your work, you are practicing DevOps. But then we have that DevSecOps. With DevOps, we try to tear down that wall between developers and the old-fashioned operations organization. But we are focusing on features. A lot of things that we're doing are based on features and getting the features out. Just look at your Scrum board or whatever Agile board you're using, and if there are stories on it, all the things that you see over there are feature things. Nowadays, we do care about things like modularity, scalability, and maintainability, but is security somewhere specified in that story or in your whole DevOps mindset? In many cases, that would be a no. So security should be part of that mindset, because, hey, we create things. So we should be scalable, maintainable, but also secure. We should make right decisions. Are you agreeing with me? So that is what this talk is about. How to infiltrate or incorporate that security mindset in that whole DevOps kind of way of working. Well, I already told you, together today we are with the two of us. My name is Brian Vermeer. I am a developer advocate for Snyk, and I am based in the Netherlands. And I do this together with Iac Scanner, who is a developer advocate for Snyk as well, and he's based in Texas. And he will do the second part. I know I just already told you this, but these are pictures, so you recognize us and you recognize the difference between us. And you probably hear it as well, because my English is not fluent and his is. Anyway, let's continue, because DevSecOps, we're trying to solve a few things. And what are we trying to solve? Well, basically, let me take you into a storyline from myself. And 10 years ago, I worked in the Netherlands for a government agency. And that government agency was kind of, how do you say it, conservative? That way of working was a bit built old-fashioned. We had an operations team. And that means that we actually went into production 3 times a year, which is interesting, because at that point you have enough time to test things out, to even do pen tests, or like do all sorts of testing and be absolutely secure, absolutely sure that everything is secure before you go to production. However, if we look into today's way of working, and moreover, if we look into, for instance, e-commerce, then I also worked in companies that we probably deployed 3 times a day instead of 3 times a year. And that changes the whole mindset. We try to speed up this thing, but again, we are focusing on features. And that's an interesting line of thought, because if we look at the whole way of how we develop software, security is not so much a thing we think about. We think about, hey, can we read this code? Can we deploy this code? Can we duplicate the service that we created? How do I put it into a container? How do I orchestrate it? And then at the end, there's some siloed department that does some security for us. And I basically hand it over. And you know what happens most of the times? Sometimes you don't hear anything of them, and it's like, okay, fair point. Just push to production, it will be okay. On the other hand, sometimes they come back with this whole list of defects and audit trails and problems. So they basically are annoying me as a developer. And that gives friction between me, my team, and the security folks, because it's siloed. However, if I do not comply or if I don't listen to them, we compromise data of our customers, because in many cases we work with PII data. And we don't want that. We're on the same team. So let's look at how software development works. It's basically, how do you say, an iceberg? So at the top of the iceberg, there is the thing I love the most, the code. I write code. I write application code. And at this case, I scaffold my application, and I'm a Java developer by heart. So I scaffold my application with the Spring Boot initializer, and it creates me a blank Spring Boot application. And I'm just using Java as a reference here. It can be any code. It doesn't matter. And it works. It works fine. And then I start implementing my first endpoint. This is my first endpoint, and the first endpoint is basically a /hello, and it goes to a page, and it brings me something. That is the code that we see, that we work on every day, that the whole team sees, and that we really, really take care of. And within code reviews and that kind of stuff, we found out that there's a security issue in here, and you might see it as well. If you don't see it, it's no problem. It's no problem. I will enlarge it a bit for you, and maybe now you see it. And maybe don't, but that's not the problem. I mean, the point here is that I'm requesting a user F from a request parameter, basically an inline parameter in the URL, and I'm using this parameter right away in the response without sanitizing it. So one thing that happens if I put up this request parameter like this, we will have a problem. We will basically have a type 1 cross-site scripting issue. And this one is fairly simple. And of course, the alert doesn't do anything, but if I can execute JavaScript, I can provide that JavaScript, any kind of JavaScript, like stealing your token or stealing your ID or stealing your cookie or whatever it is, and I can display it, or I can send it to another server. It can be pretty harmful depending on the context. And you might say like, okay, fair, but nobody does that. Well, you can also do it in different ways, like the script alert was one thing, but I can do it with a mouse over or an image tag, or like there are different ways of doing that. And we might catch this. We might catch this during code reviews, unless you're not doing code reviews or pair programming. Or what happened in the company I worked with is that, hey, let's do code reviews and give that to the junior on the team. Hey, we got 20 minutes left before we need to push it to production. Can you quickly view my code? I worked on this for 3 weeks, but can you do it in 20 minutes? And they might be looking at it and see some of the problems, but are they security aware? And this one is a simple one. But let me bring you to my browser, or to my IDE. This is my IDE, and I'm using a tool over here. I'm using the Snyk tooling within the IntelliJ IDE. And let me enlarge this a little bit for you. Let's go to the user controller, and you see the stuff that is highlighted, and what we already see over here. And let me enlarge this. You see there it found a cross-site scripting issue. It says it starts at user controller 35 and it ends at user controller 38. And it's exactly the problem I showed you before, only in a mildly different context. What I'm doing here, and if I'm enlarging the code like this, again, I'm having this parameter, and without sanitizing it, I'm over here. So having tooling available that helps you out already is a plus. So while I'm developing, I can scan my tooling and I can look at it. And hey, for instance, what it says over here is you can use the string escape utils that is part of the Apache Commons tags text package and escape to HTML, so it will not be harmful anymore. Again, this one was pretty simple, was pretty obvious, but how about this one? I'm going to show you a path reversal. And that path reversal, as you can see, is starting at file controller line 57 and ends at line 69. And what I'm actually doing here, let me go to that. If you see the code, and I will enlarge it for you again, you see that I'm inputting a file. I'm having a file somewhere over here. It's a multi-part file. And then I'm creating a path based on an upload folder, which is a static string. And I just use the file get original name. But what if my name was something like this? ... I go all the way outside of the path. I might go into a place where I don't want my user to get, but he might be able to override something like foobar.txt or whatever that original name is. And that's what we don't want. And luckily, my plugin in my browser already shows me that. And not only shows me like, hey, you have a problem, go and fix it, but also like, hey, this might be interesting to how you can fix it. If you see over here, it says like, hey, maybe we should look at the canonical path and check if that canonical path starts with whatever it's supposed to be starting with. And that already helps me from the beginning while doing my actual code, while printing or while creating my actual Java code. And it's the same for JavaScript or Python, but I just use Java again as an example. Let's get back to the slide deck. Where is it? Here, got it. So we have our code. However, and we have tooling to help us out, like the tooling I showed you, like a cross-site scripting problem, and it shows you like I can use the string utils and the escape HTML or any other thing, but it gives you a hint. That is helpful. I mean, that helps me as a developer not to only point out where the problem is, but also how to fix it. And if we do that, I already helped the security team a bit that they won't come back to me with that list of defects. You get me. But again, this is just the tip of the iceberg. The tip of the iceberg normally is just a very, very small part of it. If we look at the iceberg, then below the water, there's a lot of more stuff going on. For instance, your open source dependencies. Like, bear with me. I mean, if you write an application either in Java or in JavaScript or in Python, the first thing that you probably do is get into your manifest file and import a bunch of stuff, like frameworks or libraries. And as we know, frameworks bring in frameworks, or bring in libraries, like several layers deep. One framework consists of definitely more than one library, and each library can bring more than one library underneath. So it can go like several layers deep. And that basically is 80 to 90% of the code base. And as a development team, I'm not only responsible for the 10 to 20% that I create myself and that we vividly check for that maintainability and scalability and be very, very keen on. But it's the whole binary I put into production. So everything I import, either I import it manually or implicitly, it is something I have to take care of because as a DevOps team or a DevSecOps team, I'm caring about the whole shebang. So, okay, fair point, but how bad is that situation? Well, maybe you've remembered this case from a few years back, and this case is from an American company called Equifax. And Equifax is a company that does crediting scores for Americans most of the time. However, the company is not that's not the point. Let's go into the hack. They were using a somewhat outdated version of Apache Struts 2 in that point in time. And what happened is they built their business logic on top of that Apache Struts 2 framework. So I just assume, and I'm pretty sure about it, that their business logic was spot on. There was nothing wrong with it, but that library or that framework, Apache Struts 2, that had a vulnerability. That vulnerability made sure that people could get in, snoop around for months, and well, in the end, over 140 million US customers were affected, and their data was out in the open. Just to give you a short timeline, what happened was at March 7, 2017, there was already this breach or this exploit or this problem was already recognized, and there was already a patch available. However, on May 12th, that's basically 2 months later, the breach started for Equifax. They were in for over 70 days, 76 days in total. And at that point, the company recognized there was something wrong. So they were in for literally 4 months. And if you can do that, well, it will cost you, as in you will have to pay fines, you will have to compensate your customers, and it will do harm to your brand. At this point, it was over $2 billion. But let's go into that hack just to show you what the issue is. So I'm here in a terminal, and I will enlarge it for a bit, but first I need to go to, let me check. This is not it. This is yes, this is it. This is an application that runs on Heroku. This is a Java application that runs on Heroku, which has the exact same version of Apache struts. And as I told you, it's not the custom code that people created, not the layouts, it's the plumbing, the framework underneath. So I don't have to go into the code. No, I'm going as a real hacker into the terminal. So let's check. I have it somewhere over here, and let me enlarge this one. I will show you what the exploit basically is. Clear this one. Let me show you what's going on. What I can do, one of the problems over here is I can use a curl request, and I go to the application layer. And with that curl request, I can use a specific header. And this header is a content type. And as you can see, this content type looks kind of weird. This content type is a invalid content type. And with the use of this invalid content type, for some reason, I am allowed to utilize OGNL. OGNL is the Object Graph Navigational Language, and you can forget that right away. It's an expression language within Apache struts, and that expression language allows me to interfere with the code. I can call certain methods, but I can also call, for instance, a new process builder, as we can see here. Maybe. And that new process builder builds up a new process. And I feed this process the bash. And I can feed this process on its turn. I can feed it an arbitrary command. So interestingly enough, if this works, and now what I'm doing, I'm routing the input stream to an output stream to show you what's happening. I can basically execute arbitrary commands that are available on that system. Linux commands. So let's try that out. What we do is let's go and get the environment variables. So what I'm doing here is I'm using the header I showed you, and I'm substituting the word command for the word env. And env doesn't do much, but it shows me the environment variables on this system. And I'm not pushing it to localhost. No, let me push this to Heroku. And I'm lazy, so I'm copy pasting everything. And get this done. Let's remove localhost, and let's actually point this to the Heroku application. And if I do that, you will see it comes back, and it shows me at least part of the environment variables. And it doesn't matter if it goes into an error mode or not, because I know that now that at the server part, at the server side, it actually executed that command. And this is not really helpful, maybe. I can see the Java options and the Java home, which might be interesting. But if I can do the env command, I can also see if I can do other commands like creating files with some content, and maybe even create files with, well, basically create a script. And if I can create a script, I can come back later and execute that script. And so on and so forth. I can use that to basically step up my attack and do certain things without actually going into the code that the engineers wrote. And that's interesting. So if we go back to our application, say that if this is the full binary that you put into production, how much of that binary is actually the code that you wrote? It's probably something like this. You know, the 10%, the rest of it are frameworks and libraries that you pull in. So we take good care of that code. We do code reviews. We have maybe a checker like I showed you before. But how do we take care of everything else? The big yellow spot. How do you take care of new dependencies coming in? Is everybody allowed to do that? Maybe so, because hey, we're working with autonomous teams. But is that the right way to go? Maybe it is, maybe it doesn't. That is up to you. But say I'm seeing something on Stack Overflow and it works. Am I allowed to just push it and go and nobody checks it? Do we actually check what's in our manifest file? And how do we handle this over time? When you pick something, do you look at this library as, hey, how is it maintained? How many maintainers are there? If there is a problem, does it actually get fixed? And what about if it's actually secure or not? All things we need to take care of. And just give you some numbers, this is a serverless application we wrote some time ago, and it was 19 lines of serverless JavaScript code. It had 2 direct dependencies. And as you know, that their dependencies bring in dependencies. That was 19 dependencies in total. Okay, with 19 dependencies in total, how many lines of code do I put into production? Can be a lot, right? There's almost 200,000 lines of code. So it's not just 19 lines I wrote, because I can clearly see there's nothing going on there. But the other almost 200,000 lines of code, I'm not sure what's happening there. And if we look at Java, we pretty much have the same thing. This is a snippet, and the actual program was 222 lines of code, and it had 5 direct dependencies. And as you can see, it's already the Spring framework that I pull in and something from AWS. So 5 direct dependencies came back to 54 dependencies. And these 54 dependencies, with these 220 lines of code, in total, the jar in this case was over 400,000 lines of code. And then we can say like, yeah, but not everything is reachable, right? Well, that depends on your ecosystem. That depends on how we handle dependencies, and that depends on whatever is happening under the hood. For instance, if you look at Java, every jar that is available on your class spot can technically be loaded into memory. And we might be able to utilize this in some sort of way. And if you think about that, attacks are not just a one-hit and direct attack. So they are not always like directly vulnerable, but might be vulnerable or helpful in a chain of attacks. So if I can come in and I can connect one thing to the other thing to the other thing, then something might be harmful. And are you aware of it? Maybe you're not aware of it, that these chains do exist, but hey, we should be aware of what we put into our application. The point is that the use of open source has exploded over the last decade or so. But if you compare this, how we use our code towards how we implement and use dependencies, it's pretty weird, because dependencies are not more secure or not more insecure than our own code. We should take care of them as much as we take care of our own code. Because if a dependency is used by a lot of people, and because it's a well-known package, then an attacker has kind of a large pool of victims to choose from. If we look at the many different ecosystems that we serve, and we look at the 2 biggest ones, Maven and NPM, then we see that NPM is the clear winner of the amount of new packages that come in every year. Somewhere during 2019, they moved over that 10,000 line, or 10,000, 1 million line, sorry. That means there are a lot of packages to choose from. Also, a bunch of packages that do the same, but hey, you have to make the choice which one you pick, right? And that holds for every single ecosystem. Because every single year, new packages will get in there. But also, new vulnerabilities will get identified on top of what is already existing. And although luckily between 2018 and 2019, it went a little down. But still, you cannot explain, maybe next year it goes up. But it's on top of what is there already. So we should take care of that, and we should update regularly. We should at least be aware if I'm using something that it's not vulnerable, because most of the time it's not the top level dependencies that I bring in. No, it's something deep down, 4 or 5 layers deep. My framework uses a weird framework to do some deserialization, and if it didn't check the input right, we might be vulnerable to whatever. And do you know what's happening under the hood? Do you actually know what you pull in? Well, we asked open source maintainers in our state of open source security, like, how confident are you of your own security? And more than half, about 63% says, kinda. How much do we trust kinda? In most companies I've worked with, nothing goes into the master repository before someone checked it. So that means we basically do not trust our peers, or we can say we want at least have 2 people watch over the code before we put it in our main line. are you doing the same thing with dependencies? Because hey, these people are just like you and me. I'm an open source maintainer as well, and I make mistakes, and everybody does. But the more important question is, who is responsible for security? And it's shared responsibility between developers, security, and operations, both on the software level as on the infrastructure level. I will go into the software level for now a bit, and Eric will go into the infrastructure level, because nowadays it's not just anymore about creating the app, but also creating the environment, containers, orchestration, that kind of stuff. But in any case, it is both developers, the security team, and operations all together are responsible for everything. And from a developer mindset, that makes sense, because I make the decision how to solve certain problems in the code, using certain libraries or using certain code construction. So I also need to be held responsible for what I'm choosing. And I'm not saying you have to be punished, but I'm saying like we have to be aware of that. It's not anymore like I don't care, I just build and the security team will solve it. No, I need to take my fair share in that. So I will show you a bunch of problems that are in there already. So I'm doing some of the hacking part, and let's go into an application. Oh, that was not the intention. I have an application over here. If it runs, yes, it runs. Amazing. This is a to-do application, and this to-do application, I can do something like this: buy flowers, or well, say hello, folks. And it's interesting. So I can build up a list. Okay. Let me hide this one. In the bottom of this application, you see a link. And this link is to the About page. And you see there's a very modest About page, right? Anyway, this page is a static page served to you by the ST library. And there's a problem in that ST library. So let me go back to my terminal again. And let me go into this one. And I will. So if I'm in my application and I'm just calling this from my command line. So I say curl. I see that I have the HTML. Okay. I know for a fact that this ST library has a problem, and we call this a path traversal problem. So let's go into that. Instead of doing curling, let's look over here. Let's just move that About page away. I see a listing. That is not a good sign. That is really not a good sign, because if you see this, there might be something wrong. But what I can do as well, instead of trying to break out of the public folder as well, trying to go all the way back maybe to the root of the system. And if I do this, I will get redirected back to, well, basically this is, the H1 is goof to do. This is my home page. Because the ST library is a real library, and this ST library is created with some sort of security mindset at that point in time. Only what they did is they specifically blocked the ... Interesting. So what can we do to circumvent it, to go around this problem? Well, one of the things, and this is a real life hack, I can do something like URL encoding. Now I represent that same thing, ... in basically another way. %2e, %2e, /m. Well, just let me copy paste this for a few amounts, because if I do ... in the root, I end in the root anyway, so I can do this a gazillion times. And as you can see, I'm ending up in the root of my current local host. Fun fact, do you know if you don't specify a user in a container, in a Docker container, how does it run by default? Hold that thought. Probably Eric will tell you about it. But by default, it runs as root. So say I'm running in that container and I didn't specify anything. I'm here as root. Interesting. So I can go to any given file, say the passwd file, and I can see what's in there. So now I have access to all sorts of things on the machine or on the container or wherever you run this. And I can use this to look and snoop around to see what's going on. For instance, what I can do is, say I'm not going all the way back to the. I can just go here and say like, hey, maybe this is not interesting, but maybe I can go just Sorry. Maybe I just can go here. And I see the package.json. That is interesting for this one. Package.json. And I can see what kind of libraries you're using, like the MS library or the Mark library. Like the MS library here, I know it's difficult, or there's a problem with it. The Mark library it has a problem, and so forth and so forth and so forth. So I know that the MS library has a problem. Let's go into a DMS library for a second, and we'll do this this one quickly. The MS library has something to do with regular expressions, and personally, I'm not a big fan of regular expressions. I like regular expressions to the extent that I want to write them. I'm okay with writing them, but debugging other people's regular expressions, it's not so much my thing to do. So I can now say buy flowers and do that. Yes, I do that, say, in 3 minutes. And you see something, it does something with the literal number and the word minutes. So we can use this. It does some regular expression magic around there, but there's an issue with that. So going back to the thing over here, let me show you what I'm going to do. I'm going to use this command, and I'm basically using HTTPI to insert something into that field by saying call mom in 20 minutes, basically what I just did. And if I just call this one, it will come back and it will say to me like, call mom in 20 m. Cool. But what if, instead of doing this, I'm buying milk, and not just buying milk in a certain amount of minutes. No, let me buy milk by printing 60,000 fives and try to match that to minutes. It still works and comes back quite quickly, because what happens is it matches. And what we want is that it doesn't match, because then this regular expression goes into backtracking mode. And if it goes in backtracking mode and it doesn't match at all, it needs to look into all sorts of things and tries to do all regular expressions and match that to the literal string to see if it works. And if it doesn't work at all, it just keeps the thread occupied. That means for a node application that works on one single thread, that this can be interesting. And so instead of doing 1 minute, I just misspell it like I do with everything, because, hey, I am Dutch. So I misspell it to minutes, and doing 60,000 minutes. I know this will never match. And by doing so, it hangs. If I'm going back to my application and I'm pushing something in and I'm pushing the return button, nothing works, because we're evaluating every single valid expression that is legal for that regular expression to see if it actually comes back. And it doesn't until, well, everything is evaluated. We find out there is no legal way to do this. And then it comes back, and then all the other requests can be done. And that can take a while. You see that if I'm running this, and you see now it's back. The point is, if we're running this and it's on a single machine and it's Node.js, hey, okay. But what if it hangs and you're working on a cloud instance, or you orchestrated something like, if it's not available, maybe I spin up a new one. Then it spins up a new one and a new one and a new version and a new version. However, at that point, it's not a regular expression denial of service anymore, but I am within the cloud, for instance, I'm just draining your funds because you're using way more CPU time than necessary, and that will cost you. So how could we have found out? Well, if I go to my application.snyk.io, I go to my own organization, and let's, for instance, go to the Java project I showed you in the beginning. And that Java project, I have it here, and I connected my GitHub repository to it. And then we can see that there are a bunch of problems. And of course, I did this on purpose. But if I look for struts, I find that there are 2 critical vulnerabilities. And this is actually the one that has the critical vulnerability, because if we look at the details, I can enlarge it a little bit more. You will see it has something with malicious code in the content type. And if I just update it to the right new version, this would not have happened. So by scanning your code, either connecting your GitHub repository or do it on your local machine, because you can do that as well in the IDE I showed you with your code. Typically, we can also do that for your open source dependencies, or in the terminal, or in your CI pipeline. We could have helped you by solving this before you actually went to production. So we talked about a bunch of things now. And let me play this slide to show in window. And I showed you some hacks that were on the application layer and on the layer of your dependencies. But it goes deeper. That iceberg under the surface goes deeper. For instance, next level is containers. And this is the cue that I give it over to my dear friend Eric, because he is more specialized into containers. But containers can be either thing like Docker containers, containers on Heroku, containers created by Podman, or somewhere in the cloud. I think Eric will talk about Docker containers as an example, but I leave that all up to him. Eric, yep. It's yours.
Awesome. Let me see if I get my screen share going here. Screen share. And we'll switch to that. Okay, great. Thanks, Brian. So yeah, let's talk about what the challenges we face as developers as we start getting into containerizing our applications and then running them in something like Kubernetes. Brian did a great job talking about, all of the issues you have when you're dealing with your own code and with the libraries and all the transitive dependencies and whatnot. But there are three main concerns we now have to start dealing with when we start containerizing our applications. First of all and probably the overarching one, is just the vastly increased scope of responsibility. What I mean there is that while, knowing how to stop a SQL injection or all these kinds of things in your code and in those libraries, having tools like what Brian showed to scan your dependencies to make sure you're not in bringing vulnerabilities in, that is kind of your core day-to-day job. Operating system level concerns may not have been, and usually we've had teams that support us there. We have Linux sysadmins, or we have middleware teams that own the the app servers or whatever. And now that you're picking these new base images and you're building containers, you have to start thinking about that. You have to think about the base image I'm bringing in. Where did it come from? What vulnerabilities does it have? What are the things I'm adding to this container? Like what file system settings and permissions do I have? What users am I running? All sorts of things like that start to increase your scope of what it is to be a developer anymore. And sure, DevOps and DevSecOps has helped us by integrating our teams together with all those people that do this as a common, their day-to-day job. It's still a lot more on us as developers to take on. And honestly, we just don't have a lot of expertise in application security, operating system hardening, and tracking of, sorry, my wife just brought me some water. Thank you. Tracking the vulnerabilities of a given RPM that we're using or something like that. So having a history of doing that, where do we start? On top of all of this, business expects us to maintain velocity. DevOps and Agile and the continuous delivery pipeline is all about getting things to market faster, getting your ideation to production as fast and as efficiently and as high quality as possible. Well, when you start talking about security and adding that to a developer's plate to worry about, you can't be slowing down that velocity. Now, historically in our pipelines, security has gotten applied in a CD pipeline, usually late stage, because often it's either a manual gate that a team is going to have to go in and analyze, or if you do have automation, it's tooling that takes a long time to run. It may take overnight to run on some large, monolithic apps. And having that, you have to put that at a late stage because you can't do every build with that kind of a level of scrutiny. So having tools that can get that information to the developer faster is critical. And when it comes to containers, this is kind of one of those areas. It's like, well, how would we do that? Well, let's jump back for a second, and we'll talk about what are these scopes I'm talking about. as a developer, I mean, we've got your code. Here's, something, you might be a Python app with a Flask app, Python program with a Flask app, and you got your third-party dependencies like Brian was talking about. Now you got these Docker files. In this case, I'm thinking, okay, Python. I know Python. I'm a developer. Python 3. Which build of Python 3? I don't know. What about StressNG package? It's a Debian package. I kind of know what it is. I know our app needs it. But what version am I using? Is it vulnerable? Is it not? If it is vulnerable, how serious is it? All those questions start coming up. And then on top of that, you may have infrastructure as code coming in. You may have to be owning some Terraform scripts to set up your clusters or your servers or whatever it is you're running on top of. That's pretty, that's a lot to take on. And then finally, Kubernetes. So we all, we're here at a Kubernetes talk, right? So this is what we deal with on top of our code every day. How do the containers come up? How do they connect to each other? How do they not connect to each other? What all the stuff, and it changes 3 times a year, right? The Kubernetes API is constantly evolving. So getting your app just to run on this can make you hyperventilate. Getting it to run and maintaining its security can drive some developers nuts. I'm going to skip example. Just like Equifax, other companies have had problems with getting us all to work well together. So I'm not going to take time to talk about that. But what I am going to talk about, let's set the scene here, and I'm going to give you a demo. So actually in the same to-do type app that Brian was just talking about, but in this case, we're going to talk about a story of a couple years ago. We had that app. It's our cash cow. It's a legacy app. We don't really do much to it. If it ain't broke, don't fix it kind of an attitude. So when containers became the thing a couple years ago, we lifted and shifted it into a Java container, and we're just running it in production that way. And here's the Docker file we use. It's a basic multi-stage Docker file, and the first stage builds it with Maven. The second stage brings in our app config, or our server configs on top of Tomcat, and we're using an older version of Tomcat, but it's the one that we had when we were running it in production before containerizing. And if it ain't broke, don't fix it, right? So bring the WAR file in from the first stage, start it up. I've got that running just locally on my desktop with Docker Compose, not even putting it in Kubernetes right now, just to kind of show you how simplistic the problem, to get to the core of it, right? So let me put my hat on as the black hat hacker, and I'm looking for web servers that I might want to exploit, and I have found your web application out there. And I'm wondering, looking by the age of it, it might be a Java app, probably is running on Tomcat. Let's look at what exploits there are in Tomcat. So the Apache folks have a page, and I'm right now looking at Apache Tomcat 8 vulnerability fixes. And if I go down to this one, now I would have been searching for remote code execution or something here, but I see, there was a remote code execution vulnerability. There's the CVE. And it was fixed in 8.5.23, which means that anybody running 8.5.0 to 22 possibly could be vulnerable. Let's learn a little bit more about that RCE. So I'm opening, this is our vulnerability database page. It's just like any other CVE page. We add a bunch of extra info to it, but I could dig into this. I could go down to the level of trying to figure out, well, how does this work and how might I exploit this? But because this is a little older of a vulnerability, I notice there's a lot of information down here and references, and a couple of them are in the exploit DB, where the analysts can put, in this case, proof of concept type code that I can learn from and form an exploit from. So I'm going in here, and sure enough, here's a Python script that does 2 things. If I were to read through this, you'd see it does a check to see, hey, give me a URL. I'll let you know if it's vulnerable, and a proof of concept exploit. So I've taken that and I've copied it down to my machine, and I've put it in behind an alias. Find the right page here. And so I can just run check, and it's going to hit this is running locally, so it's hitting my IP straight over HTTP, and it says, hey, you are vulnerable, or that URL is vulnerable. And it has, just to test it, it's put a simple POC out there. So we will go back. Now this is my server. So if I just hit the top level of it, you can see the sample Apache Tomcat servlet. I could go show you the app, but that's really not important right now. What's important is now that as a hacker, I can see that POC works. It was able to inject a JSP into that Tomcat web container, which happens to be running in a Docker container. It's just A's. It's just a, hey, I could do it. But that's pretty bad as it is. Let's take a look at what happens when you run the actual exploitation. So we're going to run pwn, something else up there. Go back to my, there we go. And we'll change POC to PWN. Now I've got a nice little HTML 1.0 form here. Well, what can I do with this? I can run any Linux command I want in the container. What that JSP had uploaded is basically doing a system call, and it's calling out and saying, hey, run this. And sure enough, and bonus, I'm root. So, Brian alluded to that earlier, that, by default, most base images that you get from official projects run as root. In fact, if you just create a container on your own, if you don't specify a user, it will be root. Now, in a container, what does it matter that I'm root? I'm contained, right? Well, true. And if I do things like, I can look at Etsy, I can do anything root can do in the container. Root in a container is an escalated privilege. Let me check something here. Let's see, can I add a file into a directory? Let's see now, Etsy. Yes, I have write access into Etsy. It means I have read access into it, and I probably have it everywhere on the system. I could actually go in and I'm ad-libbing now. Oops. Remember my paths, sorry. So I could come in, anyway, I could go in, I could find the Docker layers and go dig through those. But what's more interesting is, let's say, see if I can just get out to the internet. Yes, I got a 301 from Google. That means curl is installed. Yay, that's helpful. And I have internet access. I now probably, as a bad actor, would go, honestly, right now I'm probably going and getting a script that will do crypto mining in this container until I maximize my CPU, your CPU on this node. But I have a beachhead now. Let's say curl wasn't installed and I needed it. Since I'm root in this container, let's see. Oh, there we go. It's updating its application. Yes, I can go install whatever I want. I can install curl now because I have access to some apt repo, so I can start trying to install things. I can put nmap on here and start trying to crawl out and see what else is on this node or on other nodes in the cluster or anywhere on your network, depending on what kind of firewall rules and network policies I've set up. So at this point, one would hope that at my company, alarm bells are going off. Intrusion detection is seeing things happening that shouldn't be happening. Or other tripwires you may have, other tools are detecting abnormal operations happening. That's great, but it's a little late, right? As soon as I get the first thing in here and I try to do something, I'm already in the horse is out of the barn, and I'm going to go run free. How could I have headed this off as a developer and not given my operations team software that has vulnerabilities like this? Well, that's where let's go back to my shell here. Let me kill out of that, and I'm going to, this is the Docker Compose that's just running that app. I'm gonna clean that up. I'm gonna run tool. Now I'm running our tool. This is not a sales pitch for our stuff. It's what I have and it's what I know. This is also let me start it. I can't type and talk. Container test. Actually, I need the image name, Eric. Good grief. It's early here in Texas, folks. So I'm going to do Snyk container test. And I'm going to grab, this is just the image the Docker Compose built for this. And I'm going to give it a little bit of extra info by feeding it the Docker file that formed that image. This also, if you have Docker Desktop or Docker CE, a recent edition of Docker CE, our Snyk container test is baked in with the Docker tools. So you can do Docker scan in the same kind of argument set, and it'll run the same kind of scanning. What this is doing is it's going through the image, It's looking at all the packages, all the things. It's using that Docker file to figure out what base image you're on and other information that you've done in this container. It's kind of analyzing that, and then it's going to go start querying our vulnerability database and look for CVEs of any kind that might be impacting you in this image. There are other arguments you can feed to get into more detail, but for now, let's just look at this. And sure enough, it says, hey, you're on Tomcat 8521. There are hell a lot of vulnerabilities in this because it's really old. It doesn't say that, but I know it's really old. I can scroll back and look through a lot of these vulnerabilities, and I can see things like there's a buffer overflow issue in curl. It's fixed in a new version of curl. Now, I can manually go in, given a list of problems. At least it's giving me, hey, you're on a broken version. Here's a fixed one. I could update my apt-gets to, get the latest things. But even better, it's saying, hey, you know what? Because you're on that base image, you're getting a lot of this junk. What if you were to upgrade? It's funny, every time I run this, every day it changes because the vulnerability database is always getting updated. And I love that. Yeah, yesterday it was recommending Tomcat 9, but it's saying you could do a minor upgrade to just the latest 8.5 version of Tomcat, and it will eliminate you down to 2 critical and 1 high vulnerability. Now, I prefer to have the build number on there, and we'll talk about that in a minute. But it's like, that's interesting. But it's giving me some other options. Now, in this case, Tomcat 10 is really not any better than Tomcat 8.5. So we'll table that. But alternative image types. It's saying, hey, if you use, this is completely, I ran this yesterday and I got totally different advice. So this is saying, if you upgrade to Tomcat 10.1 with the Turmarin Focal JDK, all these other options, here are different sets of vulnerabilities and how many of them are critical and whatnot. In fact, there's an 8.570 version that's only got 23 vulnerabilities. That's interesting. So with this information, not only do I have a list of what's wrong, which is what historically a lot of scanners will tell you, I now have some ideas about what I could go to. And now I can go informed. Let's say I'm a junior developer and I'm not really up on the speed on Tomcat. I can go to my lead engineers. I could go to my architects, my security analysts, my middleware teams. We can have a quick, powwow around my desk or on a Zoom and say, which of these options make sense for us? Now, in our case, I'll put on the hat of my architect. Well, we can't run on anything bigger than Tomcat 8 because our app is old and it has API library requirements. So we're going to stick to Tomcat 8.5. I'm not ready to switch to a different distribution behind it because I'm very conservative and not willing to do that. So let's just go to the latest Tomcat 8.5 and we'll investigate these other options in the next iteration. So what I would do is I would come over to my Docker file and I'm going to edit that. Now, as I was saying, I prefer to use this, actual pinned versions because 8.5 is a moving target. It's going to change. I happen to have, so here's the list of supported tags from Tomcat. If I search for 8.5 comma, usually, yeah. So 8.5 is an alias. And again, it's a moving target. Tags move around, if they're not very specific. 8.571 is the current latest of 8.5, as well as all these other tags in this list. So I'm going to use 8.571. Come back to my code, change this to 71, and we'll go back to my shell. And I am just going to do Docker compose up and tell it to build. And while that should be quick because it should be cached. So this is going to do its thing. And I happen to know from running this demo a little earlier today, I'm probably going to get a stack trace here, which is not really important to me at the moment. I need to figure out why Jaxby is not working. That's an application concern, which doesn't really impact my demo. So I'm just going to jump back over here to my browser. And this shouldn't be there anymore. Right, that's good. Let's go to the top level. Now here we see that the example servlet is gone. And between 21 and 71 build, Apache removed the sample servlet from the default container, which is good because it shouldn't have been there in the first place. But I do see that I am now on 71, which is good. So let's go back to my shell and let's see if now back in the Black Hat hacker. Let's imagine that we've checked that in and moved it forward. Now in production we're running 71. So Go rewind back in time, and the hacker's looking for vulnerabilities. He's found my web app out there on the internet, and he runs check against it, and it's no longer vulnerable. He moves on and checks the next one in his list. And I've avoided being exploited today. So given that, back over here, in our, this is a very generic software delivery lifecycle type pipeline. What I've effectively done is I've taken these little patch logos on these blocks are indications of where security can be applied generally in most people's CI/CD. I have shifted that as far left as we can go, right to the developer's workstation. And again, I'm not trying to sell our tool. There are a lot of tools to do this out there. Investigate what's best for your company. But having a tool that gives you the fastest feedback loop that you can run right there while you're sipping your coffee, about to unit test your stuff on your local machine, is key, because that is the fastest. It's faster than CI, right? It's right there on your workstation, and a tool that gives you actionable feedback is critical. Because I can get a spreadsheet of errors from any container scanner that I might be in a registry. That's fun, but now I've got to go figure out, well, which one of these is important. Having it right, having it be able to give you advice as to, hey, by the way, here's some better base images you might choose from. Or even if I did have to get into those libraries, here's versions of those libraries that are fixed. So I'll skip that one. So that's great, but there's always going to be vulnerabilities that can slip through, right? There's always going to be a 0 day out there that you didn't know, that none of the tools, none of the vulnerability databases have, that somebody's banking away to get their bug bounty at the next black hat or something. So you need to also practice defense in depth, and that's where we get into the orchestrators and the runtime environments and whatever. But the first piece, let's continue to talk a little bit about images. So your development teams need to understand how images work. They're actually not very complicated. It's just a bunch of tar files that at runtime, the container engine, whether it be Docker, Containerd, CRI-O, you name it, layers up and combines into a unified dynamic file system that it presents to the container. And it puts a read-write layer at the top for any changes, any mutations to happen. Well, minimizing the footprint of that image is critical. And a lot of new people into containerization don't really think about, well, why would I care? I mean, it's not like we don't have 10 gigabit LANs everywhere and we're transferring files at hyper speed. It's not necessarily about the size and disk storage and things like that. It's about what's in that image. And it's very similar to what Brian was saying about, yeah, that jar might have a vulnerability, but it's not in the code path. Why do I care? Well, you may not care as far as your application today is concerned, but if in this case, I might not care that curl is in that image, but if somebody is able to get a remote code execution, then you care, because now they can very simply go gather things from the internet, or they can, you name the tool. So don't put things in your images that your application doesn't need. Minimize that down. Secondly is layer housekeeping. So as you probably, if you're at this event, you know images pretty well, probably. Layers build on each other. So layer 1, layer 2 is the difference that you applied at that point, usually in a Docker file. Layer 3. So one of the early mistakes people can make is that they say, oh, curl might be in my base image, so I'm just going to do a run rm curl to get rid of it. That doesn't really work. I mean, it's still there and hidden, but if somebody does get an exploit, and heaven forbid they get root access, or I'm sorry, host file system access through a bind mount. Hopefully you're not doing bind mounts. Some kind of host file system mount. If they can somehow break out and get into the file system on the host, and they have elevated privilege, they can get into those Docker, Containerd, whatever image layers, and they can find things in there. So let's say you do have it, you have made it so I can't run curl. Well, if curl is in those layers, I can still run it then, if I can break out of that. Yeah, so I'll leave it at that. So understand how layers work together, and multi-stage build. So getting to build strategies, multi-stage build can really help you there, because that final stage, you can really lock it down. You can use a slim version of an image which has less other executables in it. You might even take a look at Google's distro lists images. Those can work depending on what your application needs. If their version of OpenJDK or Python or whatever has what you need to run your app, they're a great solution. There's no shell in Distrolist. There's no package manager. So they really lock it down well. And they also make sure you're not running as root. However, if you do need to add things, like you need database libraries or whatever added, it makes it a little harder because with no package manager, you're now becoming a bit of a quasi-system admin trying to figure out, well, what's the right place to gather a library from, and how do I make sure it's valid and up to date? You're kind of taking on a lot to modify a distroless image. You might want to do that, you might not. Other strategies, make sure your builds are repeatable. You saw me choose a specific version of Tomcat. That's so that if I build it today and then again tomorrow, that version tag doesn't move forward on me and unexpectedly. Now, it is good to continue. It isn't talk. It is good to continue to update and go to newer versions as they come out. And some people practice having the 8.5 type version in their Docker file, and then when they go to check in, they actually add the extra tag. There's lots of different things you can do there, but what you just make sure that your builds are repeatable, so that if hash ABCDE builds this way one day, it should build the same way the next day. You could actually go the other farther and use a hash in your from line and say from Tomcat blah blah blah, and then the SHA hash, and that guarantees you, because since labels or tags unfortunately are mutable, the hash isn't. So that would, that guarantees repeatability. But there's other challenges that you get when you do that. Labeling is also something that people often forget about. Docker files have a keyword called label, which allows you to apply a name value pair. It's just metadata. It's not really available to the app by default. It's not in the container itself, but it's available to container engines and orchestrators to when you inspect what's running, what's in the image, you can see those labels and you can use that for reporting and data collection. Our tools actually have a cool feature that we just added where if you're already scanning actively from the Snyk app, your Docker file somewhere in out of your Git repo, and you're scanning images from your registry, and it sees a label with the OCI standard spec for what repository is this from, it will automatically cross-reference to that Docker file, so you know when you're looking at your Docker file what images are using it. That's a whole nother demo, but the OCI folks have the specification has what they call annotations, not labels, but they have a set of these labels that are they're pretty broad. They cover a lot of things like what Git hash built this, all sorts of info you can put in here that when you look at an image now, you can know if you're standardizing on these things. Okay, it says it's this, but our standard labels prove it because I have put in the link to the CI build and I can go look at the audit trail on it. So those are good. And there's also other build tools. I mean, if you're a Java shop, take a look at things like Jib. In fact, I just blogged. If you go to snyk.io/blog and search on Jib, I just blogged on how you can use that to build your container images for running on Docker container anywhere you want. But the build itself doesn't need a container engine. It's 100% Java implementation of a container image build tool, and you can bake it right into your Maven or Gradle or Shell or whatever, however you build your stuff, and it will drop a tar file right there that is an OCI spec image, or it'll ship it off to your registry, or if you have Docker, it'll put it in your local cache. Cloud native build packs is another one. There's all the Red Hat tools that you can use to do builds. So if Docker files don't fit your needs, take a look at these other tools. Doesn't mean you have to leave your container engine of choice to use another tool as long as it's building a standard image. Finally, secure supply chain is a huge buzzword. We've been talking about it at the places I've worked for years, but it's a whole talk into itself. But what it boils down to is just like I said earlier, know where your images come from. Don't be taking willy-nilly images from the internet, from rando repositories, even out on Docker Hub or wherever. Many large companies will actually have a quarantine. Well, they'll pull the image in from Docker Hub, Quay, or Key, depending on how you want to pronounce that. Amazon, Microsoft, wherever, and they will scan, vet, certify. Yes, this is an image that we are ready to accept, and then they'll put it in your company's internal registry as mycorp/Debian or Java or whatever it is. the important thing is that you're validating that base image is what you think it is. The hashes on your from line can help with that as well. Secondly, never, ever have a human be pushing an image to a registry that will ever be deployed to your servers outside of a sandbox environment, maybe, because you can't audit that. You don't know when Eric builds a goof app and pushes it up to, our repo at mycorp.com, at whatever. You don't know what's in that, honestly. You don't know what I've done to it. But if our CI server does it and we have an audit trail around it, you have a much better idea what's in that image and where it came from. Runtime concerns. We touched on this a couple times. Don't run as root. UID 0 inside of a container is still elevated above what another user would be. And there are other things you can do at the host level, but why use it if you don't need it? You should, for instance, if you're a Node.js programmer and you're using the Docker Hub official node image, it will run as root if you don't tell it otherwise. But they include a node user that in your Docker file, you can switch context to that user and it will run just fine as that user, and you should. A little caveat there for Kubernetes: if you do switch users in your Docker file, make sure you're using the UID and or GID of the user, not the name. So if you say user node, that will work in a container engine, no problem. And it'll work in Kubernetes, no problem, unless you go into your sorry, my brain's gone, your security context and set run as non-root true, which the kubelet uses to say, oh, I can't run anything as root. If you set that to true, which you should be, it will turn around and say, oh, I can't tell it what node is because the container's not running yet. It'll look at the image and say, I don't know if that's the UID 0 or not, so I'm just not going to run your container. So use the UID in your user lines if you're shipping for Kubernetes. But like I said, root, you don't need it in 99% of business applications, because why? Why would you need it at runtime? Privileged containers, you don't need. I'll tell you right now, unless you're doing something extremely low level, like you're doing Kubernetes monitoring tools, you're writing CNIs or bug fixing on Calico or something, and needing to mess with the network stack at a low level, you probably 99.9% of you don't need to be running privileged containers, and you should be restricting it through your security contexts and other means. This also includes privilege escalation. A lot of people don't realize that privilege escalation, which is the ability for a process in a container to elevate privilege based on an SUID bit, like sudo or something, that doesn't default to false. So even if you have privileged containers, no, false, you have run as non-root, true. If there's a sudo in there, I can become root. So make sure you set to allow privilege escalation to false. Drop capabilities. Linux capabilities are those magical things they added to the kernel around I think it was the late 90s, that restrict what kind of system calls your process can make. Again, most business applications don't need many, if any, of these. So you should analyze your app. The Docker and Containerd and all the container engines, they narrow down what capabilities a contained app can have, but they don't eliminate them. And there's a lot in there that you probably still don't need. So I honestly, I would try drop all and then just add back only the capabilities your app needs if it is doing something with the network or otherwise. And there are a lot of blogs out there that talk about how to analyze your app and figure that out. So look at those. The root file system. So one of the things you saw me do in the hack was I did a touch real quick to see if I could create a file. I happened to do it in Etsy because I also was checking on the root capabilities. But if I had made that file system read-only, which tells the container engine don't create that read-write file system layer at the top, I would not have been able to touch a file. I would not have been able to curl anything in that is, dropping to the file system. Still could curl and maybe exec. I would not be able to do an apt-get install. There's all sorts of things that are blocked immediately by making your container's root file system immutable. Now, pay attention to any volumes you might also be mounting, because obviously I could shunt things over there and run them from there. But just making things immutable is always good in all over the place in cloud native. And then finally, we talked about this a second ago, deploy from known sources. Don't you set up admission control, set up OPA or whatever to say, don't allow me to pull from registries other than the one we trust. Set firewalls up so that your developers on their desktops aren't pulling from the internet's Docker Hub or K. It's just simple things like that are great ways to help protect you from bad images just showing up. Finally, core Kubernetes things. So we could talk about this for forever, but some of the big ones are secrets. Yes, they're great. However, if you're in a shop that's doing their own Kubernetes hosting, they're doing a kubeadmin install, make sure your operators are encrypting those secrets at rest. By default, if you don't do anything, your secrets are just base64 encoded in etcd, and if somebody were to get in and get etcd access, they would have the payloads of your secrets. Most managed Kubernetes now default that to their own encryption key management systems and all that. And use RBAC with your secrets. The whole point, honestly, of a secret object, as opposed to a config map object, is the fact that you can apply separate RBAC to it. And yeah, there's other idiosyncrasies about it, about the encryption and whatever. But if in general, use RBAC and make sure you're using it with your secrets so that only the right service accounts and things can get at those secrets. The security context I mentioned a couple times here. There's many things in that security context that you can lock down your deployments with. Take a look at it, learn them, understand what the defaults are. I like explicit callouts in my deployments. So in my pod manifest, in my spec, I'm going to say privileged false. I'm gonna set those in there. Just in my boilerplate, because I want to make sure the next developer looking at this understands I made a conscious decision that I don't want this to have a read-write file system. I don't want you to run as root. So if you leave it to the default, it leaves up to, well, it's not working. Let's just hack it in let us run root. No, make it be the default. Or make it be explicit. Sorry. Network policies are your friend. If you've not looked at them, they're actually not that complicated. They're people think network, oh, it's crazy. No, it's just rules about pods. How can pods talk to each other, or how can't they talk to each other? What are the ingress and egress rules on protocol and port communication? I'm a fan of the zero trust pattern, where you basically deny all traffic, so no pod can talk to each other, except for the specific allow rules you add. So allow front end namespace tier to talk to back end on port 8080, blah, blah, blah. Allow pod selector X to talk to pod selector Y, or to receive traffic from it. Those kind of rules. Do make sure, however, that if you do a deny all, that you do allow DNS, allow UDP 53, because if you don't have DNS, DNS is always the problem, right? You have no service lookup, right? And that would be bad. And finally, I've been talking a lot, sorry. Enforcement. So cluster, if you're a cluster op or if you work with them, consider tools like OPA with the Gatekeeper Kubernetes implementation, Kyverno, legacy things like pod security policy are good. They're being replaced, and I should know the name of the replacement. Oh, this kills me. I'll go look it up. But pod security policies are being deprecated, and they will be removed in I think 25. Build 25 in Kubernetes. Don't quote me on that. But enforce all these things we're talking about. The kinds of enforcement we're talking about will stop a deployment as it's submitted to the API server. That hook will come in and it'll say, no, you can't deploy this because we don't allow people to run as root. And it just won't even get into the cluster. So key takeaways from my part of the talk. The fast feedback loop is the most critical thing. Make sure your developers are getting feedback loops. Now, all these Kubernetes things I'm talking about, there are scanners for that too. So use those here in your feedback loop. Make sure a developer can see, oh, I'm trying to do this before he even commits this code, before he even tries to deploy your cluster. The build should break, or using tools like the ones I've talked about to enforce that. Make sure those tools empower your developers to be productive by giving them advice about it. And then follow all these defense in depth kind of advice to make sure that your cluster is hard to hack if a vulnerability does exist, or is a 0-day or something like that. So with that, I'm going to bring Brian back in. Let me add him back here. And I'm going to stop sharing my screen. Me add your screen back in, Brian.
I think my screen is in the background. You just have to pull it in.
There you
Yes,
go.
amazing.
Playing producer, switcher, and presenter is new to me. So
no worries, no worries. But as you can see, Eric and I talked about we talked about two things. I talked about the top part of this iceberg or pyramid or whatever you might call it, and Eric talked about basically the lower part. And with every step in this iceberg, either the top, above the water or under the water, we can help you with tooling, like Snyk code for your code, Snyk open source for the third-party libraries, Snyk container to scan your container to containers to see if there is base image remediation needed, and we've got Snyk IAC to check your infrastructure as code. But remember, it is not so much about tooling. Tooling is just one part of the solution. I mean, if we look at the solution, it is basically three things. It is culture, process, and tooling. And the culture part, I believe you should start with that if you want to be more secure aware. If we look at culture, we work with different kind of people within the teams or within the organizations. Like we've got developers, operations, security folks, and management. But we all have our different mindset. We as developers like to care about creating stuff, making sure that the stuff that we create is fast, it's feature complete, and might be even using the latest newer frameworks. But if you look at the security folks, for instance, they just want to make sure, if your traditional security team want to make sure that you're just not getting breached. However, management is pushing you out to make sure that that feature that you create is out there as fast as possible. But if we do not operate in each other's mindset, but stay in our own cubicle, then we still have that problem, because management pushing me to get that feature out, and I might take shortcuts that influence the security of myself. So we need to make sure that we create an environment that we talk to each other, that we make sure that security folks, for instance, the security team helps the development team to understand why this is important, to see what kind of way does it help the development. But also we need to buy in from management to make sure that developers get enough time to fix this as well. And because security in many cases is just not as visible. So if you look at process, the second pillar, process is important, but the best thing to do new stuff is not to create more process. And that makes sense, because we're doing this, we're good at it. And why not just look at the current way of working and try to integrate that security mindset in that current way of working? That way, the adoption of the security mindset would be way more possible and probably better than before, than if you just create more processes. For instance, like, hey, we have this gate, and make sure that everything is passed and there should be zero vulnerabilities in whatsoever before you can go to production. And if you gate people, if you gate developers in that way, they might circumvent that or go around that thing. Or, well, you get me. Just try to look at your current way of working and make sure that the tooling that you create or that you are using is helping the developers in such a way that they can keep working in the same way. For instance, if you don't have a CI pipeline, I'm just making something up. Does it make sense to make an automated CI pipeline just for the sake of security? Probably not, because, hey, developers were pushing the binaries manually. But you get how what I'm trying to say. We need to pick the tooling that fits the way you work. So if you look at this thing, and it's basically the thing that Eric showed us already, we have different steps in our SDLC, our software development lifecycle, and make sure that if a developer loves to do this in his IDE, that we can make sure that you have the tooling to scan it while the person is working on it. If it's more a person that wants to work on it from a terminal, we can provide you with the Snyk CLI. But for every step in the SDLC, we think that you need to scan and make sure that what you're doing is verified for both your application, your container, and your infrastructure as code. Anyway, if you look at this, you see that a lot of people say you need to shift left. But shifting left, there is no left in a continuous process. We need to make sure that by using the tooling in the right way, so it helps your process, that we enable the developers, that developers are aware that they can use it and that they can use it in such a way that they do not get blocked, but get helped, if you know what I mean. For instance, the base image remediation that Eric showed you is already a good step in like, hey, just switch these tools out. And then we already have a better solution. The same works for your dependencies, and the same works for your code. By not just pointing out the mistakes, but helping you out how to solve it. Combine that with the knowledge that the security team has and bring that to the teams. That will make a foolproof way of working during this continuous life cycle, because that is what it is. It is not something that has a start and an end because, well, hey, frankly, there is no end at software developing. We keep doing this. Anyway, for now, this is what we have. If you have any questions, feel free to jump them, to pump them in the chat. If you don't have any questions yet, or you feel you have questions later, feel free to ping either of us on Slack or Slack, I want to say, on Twitter, if you have questions here. This is my ending slide. I forgot to put Eric in. I'm sorry, Eric, but this is my Twitter handle. But let's see if there are any questions.
Let's see. I don't see any. Now's your chance, folks.
Well, it can be that we perfectly clear. That would be great.
Well, if it was just you, I would say that's possible. But since you let me talk.
On the other hand, it's also Friday, so I get it that people might be at that point like, this makes sense. Let me take a look at it. To be fair, the tooling that we showed you can be used for free. So just sign up for the freemium tier. Yes, you are. There is a limited amount of scans, but I think the scans are up to 200 scans a month, which is perfectly fine for and perfectly suitable for a single developer. So try it out and see what you think of it. If you want to use it in a more bigger enterprisey way with hundreds of developers and reporting, then we go into other plans, but you can still use this stuff for your own applications and containers just for free, and try it. I would say the capabilities are basically the same.
Yep. You know, while we're hanging out, I didn't, since the what I was showing was mainly container focused. There's one thing I didn't show if anyone's hanging around. This is our Iac scanner, and again, there's a lot of these kinds of tools out there. But every time I pull a file up in it, I'm kind of surprised at how many different policies they're constantly adding to this. And some of the really cool things I never realized that we check for. So this is a simple pod. It's part of a hack demonstration we do for Kubernetes, so it's obviously not good. And you get the things you'd expect, right? So here's the container running in privileged mode, and it tells you why that's bad. That's kind of obvious, and how to fix it, just like all of our tools. But it also is showing me on line 9, it's highlighting them. I was like, why are you highlighting the name? Well, it's showing me things that are the defaults that I probably don't want. Remember, we were talking about how bad defaults are for things. And for instance, it's starting to tell us that I don't have a pull policy that's set to it doesn't prevent image reuse, so I could be running with an outdated image. I already knew this. It's got memory limits aren't set. I would actually, if this was my actual organization, I would mark that as high. Honestly, you should never run without your limits, because running without limits just invites denial of service attacks or crypto miners, especially CPU, liveness probe missing. I forgot that it does. It'll tell you things that you just don't have in your pod that you probably should. So anyway, that's what I'd like to be amazed by my own tooling.
Yeah, well, it's interesting to see this. So we have some Iac part, as I told you as well, which is basically the bottom part of that graph I showed you. And I think it's interesting that we can use all sorts of tooling, because everything that we talked about is yet another layer you can be vulnerable at. It's not just one or the other. We, unfortunately, as a development team, as DevOps team, we need to take care of all of it. And it's and I guess that not every developer is very keen on every aspect. Some developers are more keen, like you, Eric, on the container part. I'm less familiar with that part. Well, I do know how to spin up a Docker container, luckily. But as a team, we need to make sure that our teams are in such a way that we can manage all these aspects from a functional and a feature point of view, but also from a security point of view.
We did get a question in. Girish is asking, if we are using a managed Kubernetes service from a cloud, are these taken care of? And I'm going to assume this is the general defense in depth kind of discussion part that I was going through. And yes and no. So managed Kubernetes services are wonderful. They allow your ops teams to not have to worry about the control plane as much. However, things that are related to your deployment may not be. And when I say that, so if I were to spin up a GKE cluster, just to use an example, because I just did this last week to test our hack demo, there's nothing stopping me from sending a deployment with a pod spec that says run as root or run privileged. And while I don't have maybe SSH access to my Kubernetes control plane nodes, if I can still, like, I don't think about how I do this. I can still get at things. So for instance, if you've got a remote code execution possibility, which you would definitely have, you could still pull your environmental variables, for instance, for a process. And if it's in Kubernetes, you're likely to be able to find the API server's endpoint. And then you can start crafting curl lines to start poking at the Kubernetes API server using the service accounts token, which by default will be sitting there in the file system of the container. And you can expand that exploit then and start getting at things. And sure enough, if you have enough things not set up, you could potentially get into the etcd and go after things. We have another talk this week. I don't have the link for it, but that our colleague Matt gave on hacking your misconfigured Kubernetes cluster that goes into that. He shows it on I think a kind cluster running locally, but there's no reason you couldn't do the same on a managed cluster. So yes, it takes care of some things, like the encrypting of your secrets is kind of, I think that's the default in most of them. Or if it's not the default, it's a checkbox if you're using the GUI when you create it to say yes, I would like to encrypt my secrets, please. So hopefully that answers your question, Girish. Thanks for the question.
I know we have a slight delay on YouTube and Twitch, because we're doing this from StreamYard. So let's just wait for about 30 seconds or something if somebody else has a question. In the meantime, I love that demo. Eric, I'm now using it. I know you created it, and I'm using that Tomcat demo now as well, because it's a pretty easy way to show that in that layer of your container base image or your container layer, without touching the application whatsoever, you can have vulnerabilities, and these are actually exploitable. So thanks for that.
Yeah, I mean, it's one of those things that I've been using Docker forever, since 2013. And I remember when I was new to it, and you think a container, as a new person coming to it, you think of a container just like a VM, and you think, oh, well, I'm protected. It's tiny, so it's just my process, and I'm protected. The rest of my kernel is protected. And no, you're not. You're all running on the same kernel. And through just, not knowing how some things work, you can exploit every other container on the host, as well as the rest of the cluster, if you really know what you're doing. So it's all right. Learning, folks.
Yes. So I think we're almost an hour and a half into this thing. I want to thank everybody who was watching this now or rewatching this later. I guess that some folks will do this on demand. I hope it is useful, and if you have any feedback, feel free to ping us either on Twitter or LinkedIn or whatever is suitable for you, or old-fashioned on email. That works as well. But do so. Try it out. Try it for yourself. If you have feedback, come back to us, and we are happy to help. So from my side, I would say thank you, and hope to see you all later.
And from the United States, across the pond, everybody, have a great day. It's 8:30. I'm going to go get some more coffee.
Well, so it's 3:30 here in the Netherlands, so it's like 2:30 in the UK. Enjoy the rest of your day, folks.
Yes. Have a great one, guys.
Bye.